So we have previously looked at pivot tables to look at comparing averages or quantitative data, such as finding average salary and seeing how that varies by program or by gender. Or we've developed histograms and frequency distributions of salary by grouping data. So now I'd like to look at specifically categorical data and summarizing it with frequency counts or percentages of who fits into various categories. That we're going to use the same data set we've used before, which is a survey from 2010 of 800 plus students that were asked a variety of questions, and the subset we're looking at has to do with their expectations of what's going to happen after they graduate. And let's start looking at their concern for finding a job after they graduate. So let's start and we'll build a new pivot table. So we'll go Insert, we're going to hit Pivot Table, it's selecting the table I've got here, and I'll click OK. And the first thing I want to look at is any concern they've got about finding any job at all. And they have all kinds of different sorts of replies here. And I'm interested in how many students. So I'm going to use the ID because every response had an ID. So I'm not going to miss any values whatsoever here, unless they didn't answer something, but that should fit in a category. As we've seen before, the default seems to be sum of ID, and we would like the count. So we go and click on the sum of ID. We click on value field settings, and we go down here and find count. So I've got 811. That's how many people participated in the study. And not all of them told me about the concern of finding a job. So let's first off look at removing those that we really can't use, those that gave us no answer, those that we're not sure at all. Okay, so now we have it. Let me make this a little larger so that you can see what's going on here. Okay. So we have a series of responses: neutral, not concerned at all, somewhat concerned, somewhat unconcerned, and very concerned. This is an ordinal variable, and Excel by default has sorted the values from alphabetically, from N to S to V. So to make it make sense to us, we should really put it in some sort of sequence. So let's move not concerned at all. Click on it, right click. I'm going to move that one to the beginning. And somewhat unconcerned, I got to move that up. Move it. I'll move it up. And I'm going to move it up again. There. Okay. So now we've got level of concern going from not concerned at all to somewhat unconcerned, neutral, somewhat concerned, very concerned. And it seems to be a very broad spread, a lot under the very concerned, but there are quite a few that really don't seem to be very concerned at all. So this is an interesting group that we're going to be looking at. And we've got 794 students fitting this description. So what type of analysis should we really be doing to this type of data? Maybe we'd like to look at what sort of program they're in. So let's go, we'll take program, move it to columns. Okay, so we've got a variety of programs here, and some of them we can eliminate right off the bat. Let's get rid of the other, because we don't know about what that is and not applicable. Then we find an engineering. It's a very, very small group, so let's combine engineering and science, take them out. And, well, we're not going to take out engineering. We're going to group them together. We've done this type of thing before. So we form groups around arts, groups around business, and this group 1, which is science plus engineering, so we'll put it together. We'll give it a new name. So now we have a table that describes the students by their program of study and the level of concern that they've got. And we'd like to do some sort of comparisons across these different sorts of things. And is the level of concern different in different programs? Among those that are very concerned, are they concentrated in certain programs? We'd like to look at patterns. And the data that we've got at the moment makes it somewhat awkward for us to go and start looking at these sorts of patterns. Because there's different size groups. I've got very few science students compared to the others. This type of table here, where we're just counting frequencies that fit into each category, is known in statistics as a contingency table. That and in a contingency table, if you've got really small samples, it often makes it challenging to go and do some type of detailed analysis. So how can we do that? How can we better explain what we've got here? And the best way is to go and start looking at its percentages. So we'll go to count of ID, value field settings, and I'd like to know, let me show values as, and maybe I'd like to do the comparisons across programs. So among those students in arts or business and science, are they more or less concerned? So I'm comparing the different columns. And so I'm going to look at the column total and click OK. So this gives me the percentages out of 100% for each program. Oh, okay. They're numbers that may be easier to understand. There's a lot of clutter. I really don't want all these decimals, the percentage signs. There's a lot of symbols here. And generally, we have difficulty absorbing information that looks in this type of fashion. That I can reduce this by removing the detail, but it's still going to be a very busy table. For many of us, it's easier when we're looking for patterns to look at a picture. So create a pivot chart. So here they've created a pivot chart for me. And they've thrown one up for a suggestion. They call it a clustered column chart. So this is clustered together, all those that are not concerned, those that are somewhat concerned, neutral, somewhat concerned, and very concerned. And I can look at the gray as a science student. So among the science students, they seem to be very concerned and a scattered bunch across the others. Among the business students, it's sort of bipolar. There are some that are very concerned, but there's an awful lot that aren't concerned at all. If I look in the art students, I have a similar pattern. It seems to be almost bipolar, that there's a group that aren't worried and then a group that are worried. So how did this chart come to be? What it took was, excuse me, let's make it smaller so we can see everything here. It took what I labeled on the axis here, on the rows, and it put them on the horizontal axis. And so I'm looking at how this pattern varies for each group. So I'm looking at how the level of concern varies across art students, or varies across business students, or of science students. And it's what we call a clustered column chart, because I'm clustering groups in this sort of fashion as we went. If I wanted to look at, change it around, who are the concerned students? That's a trickier one. Let me look at a different issue where I can flip things around more meaningfully. Let's look at where students are from and what they study. Okay. Ooh, this one is very, very busy. Let me flip back to my table here and get rid of my, I'm just going to delete my chart for the moment. So I'm looking at programs and where students are from, and there's lots of different places they're from. So let me remove those that didn't tell me. Okay. All right, that's good. But I've got certain groups here. I've got ones that are from, you notice the most are from Nova Scotia. A large group, well, let's look at here's Nova Scotia, outside Canada, and everywhere else. So let me take everywhere else. Take Alberta, press the control key, click British Columbia, Manitoba, New Brunswick, Newfoundland, Ontario. Whoops, I lost them. Do this again. Alberta, British Columbia, Manitoba. Ah, there we go. I got them all. I'm going to right click and I'm going to group them together. Okay, I'm going to call this, let me collapse them, and I'll just have 3 groups here. Okay, and this one I'm going to have Canada, outside Nova Scotia. Okay, so I've got a big, big group here from Nova Scotia, and that's 71%, and the other 29% are in these 2 other areas here. So I'm interested to know what programs students study and where they're from, and do those patterns vary. At the moment, I'm looking at by program. So let me go to Analyze. I'll have a pivot chart. And it gives me many different types of charts, all these other sorts of things. And I'd strongly recommend that you don't use any of them, especially this last one. This last one is awful. Stick with the clustered column chart. Click OK. So if you look at this, it says that obviously most of the students in all programs seem to be in Nova Scotia. And then we've got some that are from outside Nova Scotia and some from outside Canada. That in business, they seem to attract more from outside Canada. Science seems to be spread. That arts doesn't attract many students from outside Canada. So that may be one story we'd like to tell within our thing. If I went back here and I had count of ID and I hit value field settings, I did show values as percentage of column total. What would it be if I did percentage of row total? Changes my graph. So what's this telling me? It says of those students that come from outside of Nova Scotia, about 42% are studying arts, 38% business, only 20% are in science. Part of that's because we don't have a lot of science students. From those in Nova Scotia, arts is preferred, then business, and then thirdly science. But if you're outside Canada, they really want business programs and a little bit in the others. So that's what happens in my picture here. It says that um, of the art students, where are they from? The because I'm looking at percentage, my totals here are by program that are by where they're from. I'm taking this group, and this group adds to 100%. So the outside Nova Scotia are in arts or business, maybe in science, or from those from Nova Scotia, they're from mainly in arts, somewhat in business, a little bit in science. And if they're outside Canada, mainly in business. This isn't saying that we have a small number of Nova Scotia students. I'm just saying among the Nova Scotia students, where are they from? So we have to be careful when you're reading these charts to understand if you're looking at percentages, percentage of what and how you're mixing those sorts of things together. That in the value field settings, there are other things we could do. Show values as total row, column, grand total, percentage of parent row, and so on. Generally, none of those things you should touch. Either look at where are art students from and split them that way, or where are Nova Scotia students studying and look at it that way, but flip it around the appropriate way that you want to study. Remember that what's on the horizontal axis is always what we have here in rows. So if I were to go and flip things around, let me see if I can do this easily. Yeah. Okay. So I flipped things around. So now I'm looking at art students and outside Canada, Nova Scotia, and outside Nova Scotia, and outside Canada. Do these add to 100%? Well, look down here. Yes, they should. Okay, because I'm adding across here to 100. So this is now showing me among art students, where are they from? Among business students, where are they from? Among science students, where are they from? And where's the split come among those sorts of things? It's not necessarily telling me an awful lot about where do Nova Scotia students study. This is telling me about where art students are from. Okay, think hard about this. Let me go back and change it again. Value field settings. Show values as. Suppose I do it back as column total. Okay. My columns are where you're from. So from those Canadians from outside Nova Scotia, what programs are they in? So these blue columns that are Canada outside Nova Scotia will add up to 100%. And the orange columns are those that are from Nova Scotia. What are they studying? The gray columns are those from outside Canada. Where are they studying? Tricky. So we can summarize these tables in a variety of ways. Very frequently, we want to convert things to percentages. Usually that's percentage of row total or percentage of column total. But it's tricky. And it's strongly advisable that you keep both the table and the picture to remind you it's a percentage on this vertical scale. Percentage of what? In this one, it's the percentage of students from outside of Canada or outside of Nova Scotia that are studying arts or business or science. It's the percentage of Nova Scotians that are studying arts, business, or science. So it's of these groups, how are they spread? That if I change things around and make it as a percentage of the column totals, it will change the interpretation all over again, even though it's got the same labels on the horizontal axis and the labels over here. Simple, not think. It requires you to carefully think and make it clear when you try to communicate it to others. Food for thought.